In this media example, we're going to use base blocks to add and subtract integers, and then learn how to represent the base block representation with the algorithm that you're probably familiar with or remember from when you were younger. So let's look at the first example. So we have negative 25 plus negative 37. So notice there's a spot to rewrite it as addition. We don't need to do this because this is already addition. Now we need to determine, is our answer going to be positive or negative? So notice we're adding two negative numbers, and we know that combining two negative numbers creates a negative number. And to find this result, we're going to add the absolute values of 25 and 37. So we're going to add 25 and 37, and then based on the fact that the original numbers were negative, we know our result is negative. So we're going to look at a website that will show us how to set this up with blocks, and then we're going to come back here and fill in the representation here. So notice I have the problem all set up. So this dotted line is separating the two numbers. So I have 25, so there's 2 10s and 5 1s. And 37 is 3 10s or 3 rods and 7 1s. And we want to solve this problem. So let's keep track of this over here because this is going to show us how the algorithm works for addition as we manipulate the base blocks. So to combine these amounts, we're going to need to regroup anything where there's more than 10. So remember, we have more than 10 ones, so we want to regroup that into one rod. So what I'm going to do, I have 7 here. I'm going to bring 3 a little bit closer. And then we call this lassoing them. So I'm basically clicking and dragging around here, and it turns it into a rod. Notice what we have here. It carried a 1 into the tens column because now we have taken those 10 ones and made one rod. Now I'm going to physically move it over into the tens place. And notice now it states that we have 2 ones. Well, that's how many ones were left over after we regrouped. And it combined the 2 plus 3 rods plus the 1 we carried over, giving us 62. So now let's use this idea to write this on our workbook sheet. So we had 25, which was 2 10s and 5 1s. Then we had 37, which is 3 10s and 7 1s. And what we did, I'm going to use a different color, we regrouped these 10 ones and we made one rod. So our resulting answer is, let's just write this below, 6 rods and 2 units. Okay. Now let's represent this with the algorithm. So we had 25 plus 37. 5 1s plus 7 1s is 12 1s. Well, that's 2 1s and 1 10. And then we have a total of 6 10s. Now we need to remember to go back and answer the original problem. Remember, our sign needs to be negative. So let's just write the whole thing out. So we have negative 25 plus negative 37 equals negative 62. Now, since this is a subtraction problem, we're going to start by rewriting it as an addition problem and then think about our rules for adding integers. So as addition, this would be 203 plus negative 278. So now we have to think of the sign of the answer. So when we're adding a positive and a negative, the answer could be positive or negative depending on the absolute values of the numbers. So I'm just going to write these here. So we have absolute value of 203 is itself, and the absolute value of negative 278 is positive 278. So what we need to consider is the larger absolute value is this quantity here. Its original sign was negative, so our answer is going to be negative. Okay, now the corresponding problem we are going to do here, since we're adding numbers of opposite signs, we're going to subtract the smaller absolute value from the larger. So we want to find 278 minus 203. This is what we're going to compute, and then we know in the end we're going to have a negative answer because the absolute value of negative 278 is larger than the absolute value of 203. So let's go to a website to see how we could represent this with blocks. Okay, so I have the problem all set up. Okay, and it looks a little bit different for subtraction because what they're trying to show here is the first number, 278, is blue, and we're thinking of that as positive, or the first number, and the blocks in red are what we're going to subtract. Okay, so when we write this by hand, we're going to cancel out the values, but here this is what's going to happen. I'm going to start with the ones place, and again notice what happens here. A negative and a positive cancel each other out, just like a negative and a positive chip. Now 203 is positive, but since we're thinking of subtraction, we could think of them as canceling out. Okay, so now notice this says 75, so our goal is to cancel out all the red blocks. So for the ones in the tens place, there's no red blocks left. Now we're going to cancel out these. 100 cancels with another 100, and our final result is 75. Now to represent this with blocks on paper, we'll start with our 278. So 200, 1, 2, 3, 4, 5, 6, 7. And here are 8 ones. And we will cancel 203. So I'm going to draw the 203 here. And now let's use a different pen, or you may want to use a highlighter. I'm going to cancel this amount from the 278. Well, these cancel, and 1, 2, 3, these cancel. So our result is the 70, 1, 2, 3, 4, 5. So we found that 278 minus 203 is 75, and then remember our final answer is going to be negative. So let's write this in terms of the algorithm. 278 minus 203. Well, 8 minus 3 is 5. 7 minus 0 is 7. And 2 minus 2 is 0. And when that's the first digit, we don't write that. So our final result will be 203 minus 278 equals, remember our answer is negative, negative 75. In this last example, we are going to take 823 and subtract negative 107. So let's start by rewriting this as addition. So this would be 823, change subtraction to addition, and add the opposite of negative 107, which is positive 107. So this problem is equivalent to adding two positive numbers, 823 and 107. So when we add two positive numbers, our answer is positive. Okay, now let's look at the website to see how we'd represent this with blocks. Okay, so I have this all set up. Notice it says 823 plus 107. I know there's a lot going on here, but there are 8 there. This keeps track of them. So above the dotted line is 823, below is 107. So now let's regroup when necessary. So notice we have exactly 10 ones. So we're going to need to group these together. Into a rod. And notice there's a 1 over the tens column now. Now I'm going to carry it over into the tens place, and notice that it placed the 0 ones once I carried. There's the 1. It summed up the number of rods, which is 3, and there were less than 10 hundreds, so it didn't need to carry over to the thousands place, and we have 930. So now let's do this on paper. So we have 823, 3, 4, 5, 6, 7, 8 flats, 2 rods, and 3 ones. Now I'm going to write 107 in green. So 1 flat, and 1, 2, 3, 4, 5, 6, 7 ones. Okay. Now we're going to regroup anything where there's more than 10 of a unit. So we have 10 ones. Let's circle this in, how about orange? So we're going to take these and replace it with 1 rod. Okay. So let's put the 1 rod up there so we remember what it is. So we replaced it with a rod. And now we can see our total is still 1, 2, 3, 4, 5, 6, 7, 8, 9 flats, which is 900, 3 rods, which is 30, and we don't have any units left, so we have 0 units. Okay. So with the algorithm, we would write 823 plus 107. 7 plus 3 is 10, so 0 ones and carry the 10, carry the 1. Then we have 3 tens and 9 hundreds. So let's write the full problem, and we'll use the initial problem. 823 minus negative 107 equals, and remember it was 2 positive, so our answer is positive, 930.